So I may introduce the last speaker, who is Zenon Nieckarz from Poland. And we will talk about monitoring of air quality and perspective for health environment. Thank you for your presentation.
Welcome everybody, thank you for the invitation. My name is Zenon Nieckarz. I work at the Faculty of Physics, Astronomy and Applied Computer Science at the Jagiellonian University. During my talk, I will try to explain some and give some information about sources of air pollution, particulate matter and its respiratory deposition, measurement techniques and calibration, monitoring network, and results, some case study. And air pollution is came from different sources. For example, from natural sources like wildfires. We can see a map of the January 2023. It's average map from a whole month. We can see that these places where the wildfire is many in this month. So next is volcanic eruption. It's big events sometimes happening on the Earth in different places. The next example of natural sources is Saharan dust clouds. They start from Sahara, from Africa, and going typically to Atlantic Ocean area and sometimes to South America, but sometimes the advection changing and this cloud going to Europe, to Poland. We can observe that situation also over Poland. So, but the most problem for us is particulate matter sources which we control. It's also traffic, homestones, boilers, industry, and we can see two pictures from electron microscope image from negative, positive. I don't know what is better to see on this presentation, but we can see that there is not ball regular, but different shapes and different chemical composition, as was presented previous. Some example, and if these particles are smaller, then can deeper penetrate to lungs in human body. So it's particle deposition mechanisms. It's easy to explain by internal impaction, electrostatic interaction, sedimentation, and diffusion. Then it's much more complicated to analyze chemical and biology path. So, if we want to know how quality of air is in different places, small society is having this possibility. So, at our university, we develop develop from project to final product. This low-cost monitoring station. Here's short characteristic of this apparatus. It's 1 minute average from 30 samples is recorded. We measure typical PM indices like PM1, PM2.5, and PM10 as microgram per cubic meter, and also number of particles per liter for different size of diameter, this particle. So also we measure typical meteorological parameters. Because this is low-cost solution, we want to check this quality of data. We built a calibrator. This is closed test chamber O-shape controlled test condition, dust injector. We used reference dust. It's automated process to calibration of this or other external low-cost sensors. We compare our results with measurements made by station management by regional inspectorate. We can see that correlation is good. Our low-cost station working as university monitoring network. Its station is located in villages around Krakow, and everybody can free and unlimited online access to results via the website. All data was management and archives by infrastructure of the Jagiellonian University. Short characteristic of the monitoring network, and we have preliminary and periodic calibration of monitoring station, continuous measurement, easy power supply, measurements in open area, and plug and play concept. Here we can see location of our 12 station working for the Kalwaria Zebrzydowska. We cooperate with this municipality, and this page is also compatible with the mobile devices like phone, tablets. What we do with our data, we prepare reports for local government, and of course we use this data to scientific study. We publish scientific papers concerning at PM10 concentration and another statistic analysis and other. As a part of the project, we cooperate with the local governments, like, for example, Kalwaria Zebrzydowska, and the research units, especially with Collegium Medicum of the Jagiellonian University. We study different aspects, for example, aspect of outdoor physical activity. We can see results from Czajowice, village located north of Krakow and southwestern part of Krakow. We can see that in Krakow it's not comparable air quality like Czajowice, because if we requirement PM10 below 20 microgram per cubic meter and study hours between 10 and 14, we can see that in Czajowice we have 70% of days, but in Krakow it's only 61% of days with this quality of air. In long-term changes and perspectives, in the study area, we observed that average number of days when the PM10 exceeding 50 microgram per cubic meter, it's going down. It's results from 2018-2024 for the beginning of the heating season. We can see results for October and November separately. It's a regional average trend. So if we want to say something about total deposition of the particle matter in the human respiratory system, we can calculate this parameter, total deposition. It's, but we need some information about density concentration, but important information we need from deposition fraction in the human respiratory system. We can see figure on the slide. We can see that at the rest time, when person is at the rest time, the deposition fraction is bigger than exercise, but more important information is that the deposition fraction for children is bigger than adults. Its result is its result we can find in many papers. So we must protect children from poor air quality. We check how looks like the situation in our data. We check this distribution during the time. This is average results from 4 years. We can see two curve, one for cold period, second for warm period. This is three places, and we can see that the daily distribution, the average daily distribution, is very similar. Another study is about concern how big deposition is in the lung when we have average marathon finish time. In Krakow it was about 4 hours 30 minutes, and for leaders marathon finish time it was about 2 hours. So we can conclude that the bigger deposition is for the average marathon finish. So the leader is leader in the time and leader in the PM deposition, for good meaning about health. So another study is compare rest time and exercise time, and we can check how many PM10 particles could be deposited during 1 hour when we have time at the rest and time of exercise, and the same level of PM10, 50 microgram per cubic meter. So we can see that during the exercise, finally, the deposition rate is five times bigger. Our new technical possibilities, it's wide range aerosol spectrometer. It's a very expensive device. It's there inside is installed two different analyzers. One using light scattering at single particle with diode laser, and second using electrostatic classification in the differential mobility analyzer and detection in condensation particle counter. So it's a little big and heavy analyzer, but we can measure now particle size range from 5 to 350 nanometers in 128 channel, and second, it's particle size between 25 nanometer to 32 micrometer. So in 31 channels. So it's a big instrument, and its first test, for example, air conditioner room. We can see here on this figure, one axis is time, second axis it's diameter of particle and concentration. We can see after the opening the window, the concentration going up. We can see clearly that this was in this moment, and distribution of particle diameter distribution was changed and going up. So it's our just by instrument. So this are totally first results. So at the end, I want to say the first and last sentence is for us very important because and the scientific, we can see that the scientific approach support local government, and if possible, outdoor physical activity should be done when air pollution is lower. This is especially important for children and at-risk groups. So, thank you very much.
Thank you very much, Professor Nieckarz, for very interesting lecture.